good coffee break. And we're going to continue the composition talks with a talk from Shalini Punjabi from York University and NCAS. He's going to talk to us about 12 years of VOC monitoring at the Cape Verde Atmospheric Observatory.
Thank you, Alex. So, Shalini Punjabi from University of York. I'm working from Professor Lucy Carpenter and Professor Ali Lewis. And I'm going to talk about hydrocarbon measurements from Cape Verde Observatory. So after FAM aircraft, we are going to Eastern Tropical Atlantic region. So since 2009, Cape Verde has been a global station. So a network of 31 global stations, and you can see the unique position of Cape Verde is the only Eastern Tropical Atlantic Observatory that measures VOC compounds. Exactly where these Cape Verde Islands are. These are off Northwest Africa. And you can see from this that it can receive air masses from different regions, mainly Northern America, Sahara, Africa. So actually this Cape Verde Island is a group of 9 islands. And this observatory is based in São Vicente Island. North of this island is Mindalo, it's a city, and eastern part of this island is called Calhau, and north of this Calhau is actually Cape Verde Atmospheric Observatory. You can also notice in this picture that CVOO, its sister oceanic site, is also upwind of this site, and these two atmospheric stations are atmospherically correlated, related to each other. This is a volcanic island and pretty much flat. So measurement began in year 2006. You can see very basic facility, few measurement equipments, VOC, ozone, CO we started doing in 2008. And 2014 was the year when Cape Verde was extended to 140 square kilometer, and we had containerized laboratories, guest laboratories. In 2016-17, campaign were also being organized, and German container Tropos group launched a balloon, and they did some cloud experiments and meteorological profiling. So currently, this looks like that. So we are seeing 2 container, Cape Verde and German container. We have guest laboratories, and we can see that pretty much 95% time this wind direction is from northeasterly. So how this is housed in a protected, in order to avoid these corrosion from a sea region, we have a permanent staff, Loish Mendes. He does day-to-day care and maintenance. These are to show you what species we are measuring. SO2 analyzer and GC top MS is a recent addition to this suite. So these are classification of air masses. These are produced by Dr. Joey Fleming from University of Leicester. So name dispersion model is used to see origin and trajectory. So we can see that North America, South America, and Europe, Sahara, Sahel. So 8 different types of air masses arrive at this site. So I have plotted ethane time series using color as an air mass, just to, to see that in winter, 2 legs, December and January, February, this green, blue, and purple color are prominent, which means that air from Sahara and Northern America are coming. And summer, yellow and red color prominent, showing that this African coastal air is coming. These are the species we measure, light alkanes, alkenes, alkynes, a limited number of oxygenates, and DMS. So instrumentation involved right from the starting until May 2013, that was GC 6890 with home-made pre-concentration system, FID. Basic system is that this moisture is removed from air and then is trapped at -20°C and then flushed into GC column with carrier. There are 2 columns, plot and low ox, one for hydrocarbon and one for oxygenate, and these are detected with FID. And then time came to upgrade our system in June 2013. Pretty much same concept. GC 6890 was replaced by Agilent 7890, but this time pre-concentration system was marks commercial pre-concentration system. Water removal was done by Stirling cooler, and overall trapping temperature, sample volume, these were being recorded very correctly. This is to show you that over 12-year period, how calibration or instrument performance look like. On y-axis, I have plotted ethane per carbon response factor, normalized with propane per carbon response factor, just to avoid, day-to-day change to the instrument in terms of sampling volume or any other change. So you can see that how ethane per carbon response factor is behaving over that period. So we use NPL 30 component mix to calibrate our system twice in a month. And this November, we are having audit for VOC at site from WCC VOC. Data from 2012 onwards are very intensely, thoroughly checked, and these are got ACTRIS label. So within ACTRIS framework, these are very thoroughly quality checked, and their procedure and protocols are followed. Here, reference station Hohenpeisenberg in gray color is shown. Every year we compare our data with this station, monthly comparison and yearly comparison, because every site has its characteristic ratio. Data are submitted to EBAS, WDC-RG. So you can find within one framework this NILU EBAS. So you can choose either ACTRIS, you can choose either WDC-RG. If you are choosing ACTRIS framework, then data are available from 2012 onwards. And if you are choosing WDC-RG, so right from the starting until 2018, you can find all Cape Verde VOC data. UK repository BADC-CADEA also has same version. This is to show you 12-year long hydrocarbon time series, ethane, propane, butane are shown here. That show very good time series. So we can see that in winter, late winter, so maxima, and in summer period, the minima, that photochemistry is driven by minimum OH and high OH in winter and summer respectively. I have chosen ethane and propane just to show you how, because ethane has a very long lifetime, around 2 months in summer and 6 months in winter. So that's a very good species to study long-range, long-term change in on global scale. So you can see that how ethane and propane over that time period look like. So we can see this increasing trend until 2012, and then if you have a closer look and we deseasonalize ethane's series, seasonal component is separated and trend component is observed. So we can see that now these trends seem to be stabilized. So this is a study published in Nature that showed that these increase during that 2012 to 2014, that was in accordance with oil and gas emission activity that was increased in US, unconventional these things. So you can see from this plot that 10 years of NMHC data collected at 44 remote global sites, so flash samples as well as first time in situ data were also included from Hohenpeisenberg, Rigi, Jungfraujoch, and Cape Verde Atmospheric Observatory. So this plot is showing that how ethane in northern hemispheric site is increasing PPT per year. So round circle is flash sample, square is in situ samples. We can see that Cape Verde is square, and in 16 to 49 PPT per year increase. But if we look at this US region, the middle and eastern Atlantic, they are colored red. So that means downwind of that fracking sites, you can see that how Atlantic Ocean site is also being impacted. This is just to show you that how this increase was in accordance with oil and natural gas. So upper panel is oil production, natural gas production. Right-hand scale is showing that million barrels per day and a billion cubic feet per day. So if you look at this plot, you can see that less than 15 BOE, barrels of equivalent well per day. These are quite steady. But when it comes to do 100 and between 3,000 this sector, then they increase during that study period. And that clearly suggests that these activities were impacting composition of this observatory. Soon after that paper, this study came. So this study compared all northern hemispheric ethane emissions with this model and found this discrepancy that the model underestimates these fossil emissions. So to show you, so there are two panels, pre-industrial ethane and present-day ethane shown. Pre-industrial ethane, you can see that observed is black, and baseline 1750 corresponds to community emission database inventory. So when baseline includes geologic emission, then it compares with observed data. With no geologic emission included, then it's comparatively less, or almost 50%. But when we see our current day, so they have chosen 2011 observation data. And when this baseline community emission database includes geologic emission, still, these are 50% less. So what they did, they replaced this baseline 2011, they replaced this database with alternative emission model, alternative 1 and alternative 2, and they applied it to all northern hemispheric sites. So I'm showing here that how Cape Verde site look like, so ethane and propane. So when they applied this alternative model 1 and 2 to, so we can clearly see that in winter, how this model compared very well with observed, and baseline is, so that means in winter, air coming from Sahara and oil and natural gas region from North Africa. So when these things are replaced by a new database, then that compares very well. So the key messages to take is that this northern hemispheric ethane emission should increase in accordance with oil and natural gas production activity. And this ethane and propane emissions, they can be reproduced, provided that geologic emissions and these anthropogenic fossil fuel emissions, factor of 2 or 3, are included in the model current inventory. So that's it.
Thank you. So I had a question about this point of pre-industrial concentrations being reproduced by including geological sources. So I guess pre-industrial emissions are very uncertain. So how big is this geological source relative to the uncertainty that we think, say, from fires and
I think volcanic are mostly, you imagine from this, when it compares very well, that in prehistorical times, pre-industrial times, so these geologic emissions, volcanic and degassing on these kind of things were the highest source of ethane emissions. I assume so.
Any more questions? I guess one general other question for me. So what does the next 13 years look like for Cape Verde? Is there plans for more expansions? And
in terms of
observations?
What do you mean? So
you talked about the observatory getting bigger over time.
So in terms of in extension, so
yeah.
we I think pretty much we are very fully equipped gas laboratories, and so people are welcome to come and do intercomparison and all other exercises they want to. So it's at the time fully equipped gas laboratories. So let's see how we are funded, and accordingly we might plan to do more things. What do you think, Katie?
They need a bit more infrastructure. They have power is limited to extending too much, but minimize. Reduce our consumption now with improvements in technology, we can make more measurements.
All right.
Just one thing, anybody want to do anything modeling or data, please feel free to use. These are freely available, and any intercomparison or any activity which you would like to contact to Katie. Thank you.